Hi everyone. This is an example of a combined gas law problem. Here we go. A balloon containing hydrogen gas at 25 degrees Celsius and 100 kilopascals has a volume of 8.00 liters. Our job is to calculate the volume of the balloon if the temperature decreased to negative 30 degrees Celsius and the pressure dropped to 38 kilopascals. One thing that will stand out when we encounter a combined gas law question is just the amount of information. Look at, there's 5 numbers in the question. 1, 2, 3, 5 numbers in the question. We're looking for a 6th. Wow, it's got to be a combined gas law question. Sometimes it might be hard to decide, is it Boyle, is it Charles, but as soon as you see all that information, it's combined. Be on the lookout. We still might encounter sometimes STP or SATP as a shorthand way of indirectly letting us know a temperature and a pressure. I might feel comfortable diving right into the work. However, it's worth it sometimes to slow down, especially with the combined gas law questions. With the labeling, the interpretation takes on a little bit more importance than before. A balloon containing hydrogen gas, it's at 25 degrees Celsius. Oh, that's a temperature. It's T1. And 100 kilopascals. Oh, kilopascals, that's P1. Notice the and links those two values together. They're both the number ones. Has a volume of 8.00 liters, period. There's the V1. Notice that all of these ones, the P, T, and V, were all in one sentence. They weren't scattered randomly throughout. They're all isolated in the same sentence. Now we have the second sentence. Calculate the volume of the balloon. Oh. Question says, please find V2. If the temperature decreased, okay, that makes sense, decreased to minus 30, it started at 25 and then decreased, okay, that's adding a logical connection between those two temperatures. That minus 30 is T2, and the pressure dropped. Started at 100 and it dropped, okay, there's another logical connection there. And this is P2. We don't have to dwell on it. However, there's lots of connections, there's lots of ways to make the decision, oh, is this a 1 or a 2? Once we have those labels done, start to think about the formula. If you feel comfortable writing it down, do it. You don't have to. It's P1, V1 over T1. It's P2, V2 over T2. Your personal style, maybe you don't need to write that down. Maybe you do. Do what you need to do to figure out the answer. We need to manipulate this equation in order to isolate V2. Our first step is to multiply both sides by T1 and T2, which is easier to say. Let's cross multiply. We cross multiply. That's going to give me P1, V1, and that T2 goes up there, T2. That's going to equal P2, V2, which were already there, and the T1 comes up. Now I'm looking to isolate the V2 variable. Here it is. I need to divide by P2 and T1, and I need to do that to both sides. Divide by P2 and T1. Do the same thing to both sides. And now, here the P2s cancel, and the T1s cancel, which leaves me, by formula, V2 equals P1 V1 T2 over P2 T1. Now, if I have the correct formula and I have these labels, let's make sure I get the numbers in the right spot. This is P1. That was 100 kilopascals. 100 kilopascals. V1, the first volume over there, 8.00 liters. And now T2. What was T2? Negative 30. Maybe you're the kind of person, maybe you want to work the conversion into Kelvin separately on the side first, and just put the final answer right here. I'm not that. I'm going to show it like this. It's minus 30. I'm going to add 273.15 to convert it into Kelvin. This is over P2, the second pressure, 38 kilopascals. And T1, what was T1? 25 degrees Celsius. 25 plus 273.15. Lots of buttons to push. If I made it this far, I hope I can get the answer. Let me be careful. There's so many buttons to push. I'm typing away. 100 times 8 times negative 30 plus 273.15. That's divided by 38 times 25 plus 273.15. And that works out to be 17.1690336. Try it out yourself. See if you can get that answer. Finally, I need to think about my significant digits and my units. 25, that's 2 sig digs. 100 has 3. 8.00, that's 3 sig digs. Negative 30 and 38, that's 2. I have some numbers with 2 significant digits and some numbers with 3. The smaller one is 2. So my final answer must have 2 significant digits. When I round this off, it's 17. When I look at the algebra here, I can see that the kilopascals cancel and the kelvins cancel. This leaves me liters, or the units are going to match for the volume. Because the V1 was in liters, my answer is going to come out in liters. When we're working with the combined gas law, it's really manageable, but there's just a lot more information to deal with. There's extra emphasis on being organized. Throwing some labels into the question is a great thing to do. Don't forget to convert to Kelvin. Take your time with the manipulation. If you feel really comfortable and you can skip some of these steps to go faster, by all means, do what works for you to arrive at the answer. Watch those units, watch those significant digits in the end. And I hope that helps.